Today I'm going to talk about those special inequalities. When you solve them and the variable disappears, now what? I'm going to start with an inequality that is not going to be special. It's going to have one solution so that we can get some of the basics down. First of all, whenever you look at something this big and it has parentheses, you always want to get rid of the parentheses by using the distributive property, just multiplying the outside number times each term on the inside. Next, if you see that you have x's on both sides, remember the goal is to get x on one side and know what it is, either less than or greater than. And so if you have x's on both sides, that becomes a problem. So I need you to deal with that situation next, before you touch the 12, before you touch the 7. And so when I look at this, I usually always look to see who has the least amount. And I see the 2x is the least amount, and I get rid of it. But to keep things balanced, I need to get rid of it on both sides, and I line it up with its like term. 3x minus 2x is just 1x, or x plus 12. Alrighty, and now it's pretty simple. Something that we've been doing for a while. X is less than negative 19. So this is a one solution inequality, but now that we have the basics, let's look at the ones where the variables disappear. We'll start this one by using the distributive property again. Just rewrite this side. And then just like I said before, you want to deal with this whole idea that I have a variable on both sides. We've got to get rid of it. I have the same amount on both sides, so when I do minus 3x on this side and minus 3x on this side, they're both going to cancel each other out. Some people will see 3x minus 3x and think that that's an x. No, that's 0x, and 0 times x is just 0. So gone, gone. And I have a 20 is greater than 12. At this point, you have to ask yourself this question: is that a true inequality statement? Is 20 greater than 12? Yeah, that's true. And so when it is a true statement, when your variables are gone and you have a true statement, then the answer is all real numbers. And what that means is that every single number in the world put in for x will make that inequality true. All right, let's look at this one. Again, I'm going to use distributive property. Not every one of these inequalities would have a distributive property, but I think it's good to practice that too. Especially here, negative 4 times positive 1 is a negative 4. And so instead of saying plus negative 4, I'm just going to make that a minus 4. It's the same thing. Alrighty, then I'm going to get rid of my variable next, take care of that problem by doing its opposite, which is a positive 4 on both sides. Got to keep it balanced. That disappears, and I have a 2 is less than or equal to negative 4. Is that a true statement? Is 2 less than negative 4? No, that's false. And so when it's false, your answer is no solution. That means there is no number in the world that you could put in for x and make that original inequality true. There are some texts that will call that the empty set. Now here's a fun one to ponder. Let me go ahead and do my distributive property on both sides. Show you what I mean. 6x minus 12 is greater than 6x minus 12. Now stop for a minute. When you had the equal sign and you saw that both sides were equal, this is about where maybe you stopped. But I don't want you to stop here because this is an inequality. I want you to go on and let's get rid of the 6x on the left side, which of course then gets rid of it on the right side. And we want to get to a point where we only have numbers. And so I want you to look at that for a second and say, is that a true statement? Can a number be bigger than itself? No, so that's false. And the answer here is no solution. What could have happened to have made that very simply an all real numbers? Well, if it had said greater than or equal to, then although negative 12 could not be greater than itself, it could have been equal to itself. All right, I hope that helps. Go and have some fun.